Hello everybody, happy Monday. How are we all doing today? How are we all good? So, we're going to get cracking. We've got interesting ones. We're starting a bit earlier today, and that's, again, this isn't a habit forming thing. Last week we started half an hour later. This week we're starting an hour earlier, but we are going to be here for about 2 hours. So it's not the case of we're finishing early. We're going to be here for a while, all going to be good fun. So what I wanted to do, as you may have noticed, we've had a bit of a theme over the past few weeks. Oh, let's go on to the next slide. We've been having a bit of a theme over the last few weeks, and this theme has very much been around load CSV, modeling data. And the reason behind this is we get a lot of questions around, how do I deal with nulls? When do I change my data model? So when is something a property? When is something a node? When is something a relationship type? That kind of thing. And this has been on the cards for a while. And I did a bit of crowdsourcing before Christmas to get input on, when you were starting this journey, or even if you're on this journey now, what are the things that come up that you want to know about when it comes to loading the data and that kind of thing. And what I want to do now, I want to take the time, this time today, and maybe we're going to do a few, is that I'm going to go away and start building out a bunch of things. I want to start building out some blog posts, video snippets, and that kind of thing based on your input. So based on the things that you raise, the questions you ask, that kind of thing. And what I want to be able to do is have this whole sort of set of information that explains what's going on. So I'm going to touch on that in a second. So I'm going to talk a bit about the rationale, what we're going to do here, what's the plan, what's the goal. And then what we're going to do is we're going to create some sample data. So I'm thinking of people and cars, because we have, I think if you remember, we've got Jane owns a car in one of our sites, for example. But by all means, user participation. If you're going, Lou, that is so boring, like, let's do something else. Suggest your ideas, we'll have a look. So we're going to hand generate some data. And then what I want to do is then spend a bit of time on all things modeling. So what we'll do is we're going to take that data and put it together what we think it would look like in third normal form. So if we were doing this, if we were normalizing our data in a more traditional means, what does that look like? And I have found an online UML class diagram editor. So we have something to pull a diagram together. It'll do, it's good enough for what we're looking to do. And then we're going to do equivalent exercise with a graph, think about graphs. So we're going to do this in arrows. So we're going to start that direction there. And then what I want to do today, we should have plenty of time for this, is let's start thinking about how that data model evolves. So how does our graph data model evolve as the question changes? So this is going to be very much question driven. So you see, as we iterate, you'll see, aha, right, this is when we change things. So that's the plan for today. If you've got any questions, if you've got any comments, put them in the chat. I'm keeping an eye there. Very keen to get your feedback on that. So let's talk a little bit about the rationale. So I've touched on it a bit, but what I really want to do is I want to create a collection of resources. So if you're starting out, you've got something nice and friendly that you can step through. So it's, by example, I want to create a bunch of examples to work with to try and answer these really commonly asked questions. And we're going to build something together with this. So that's the goal. And the what is, like I said, some video snippets and blog posts, maybe some other stuff, don't know. The how, so, what we do, the how, the why, oh, never mind. So the how, what we're going to do, well, we're going to start out with modeling. So what we're going to do is we're going to create some faux data. And again, this is up to you if you've got some ideas, shoot them in. Otherwise, I'm sticking with people and cars, and people and cars is fun. People and cars is fun. So we're going to do that. We're then going to keep working with the modeling. So I'm going to stick with the modeling for now. We'll look at loading data next time. But what I'm going to do with the loading data is I'm going to show you how we step-by-step refactor our data. So we've got two angles of how we can look at this. We can either go that, well, I refactor the data model and then I just get rid of all my data and reload it. But the other approach we want to look at as well is, well, I've already got the data in the database. I don't want to load it again. How do I refactor my data based on the data model changing? So we're going to look at that as well. So the how do you do this? And then that last point, the really, really popular question, which is spotting when to update the data model. When do you go, right, I need to update my graph data model? So what are those trigger points? So you've got an idea, so you've got the principles around that. So that's the goal of what I'm trying to do here. And again, if you have any questions, pop them in the chat. I am having a look, and then let's have some fun. So let me just reshuffle my windows ever so slightly. So it's just so I can make sure I can see any questions that are coming in. I do not want to miss any of your questions because they're always amazing. Okay. We are good to go. So let me just show you a couple of tools that I've found. So obviously arrows, we know arrows. So this is where we're going to do our graph data modeling. And I have found this tool online, so a tool called visual-paradigm.com. They have an online UML class diagram drawer thing, so I'm going to use this for when we do our normalization of our data. And the reason why I'm taking both of these aspects is just so we can think about how we're moving back and forth between them. So some of the similarities and some of the differences. And again, if you've got any questions, fire them in. It's all going to be fun. I will do the, don't worry, these videos aren't going to be the content that come out. This is our working session together as a group, and you can join in and work. And then obviously I will go away and look at how we do something a bit more snipped down and polished. So we have like bite-sized things rather than 2-hour videos. All right, for the data. So no one suggested any data. So it's people and cars. You were warned. So let's generate some data. So we're going to have a person. So let's say we've got a name. So owner name. I'm going to make the import easier on myself. I'm going to do it like this. Okay, we're going to owner name. And what else do we know about the owner? They will have license number. Do we want to do license number? Oh, why not? We can get rid of them afterwards. So let's just work through some fields here. Oh, you know what I'm tempted to do, actually? I might steal some data from the murder mystery thing, but we'll stick with the fields for now because it doesn't matter. We're going to just look at some modeling, and then I will generate some faux data at a later stage. And this will be the same data that we'll keep using. So I've got license number. So this is the driving license number. That's probably all we want to keep about the owner for now. And let's say this owner has a vehicle. So let's put vehicle reg. That's a unique property. So our unique properties here would be the license number and the vehicle reg. So license number for the person and vehicle reg for the car. So this vehicle is going to have make, have a model. It's going to have, oh, got a question up from Alex. License type, I may drive trucks or not. Yeah, so I don't know what the system is globally. So I'm appreciating now there's going to be lots of different systems in play. In the UK, you have one license number, and then what they do on that license, they'll upgrade what vehicles you can drive. So for example, if you have passed your test and can drive a heavy goods vehicle, then you would still have the same license number, but they'd add on there that you can also drive an HGV and a truck and trailers and all of that good stuff. So I'm going to assume it's the system here, and you're just going to have to forgive me that there's different options around here. Okay, so you've got an owner name, a license number, a vehicle registration. We've got the make of the vehicle, the model of the vehicle. We should probably have a registration year as well. So let's do a reg year. So when I say registration year, I refer to when did that particular... Oh, actually, I've just realised that this information, some countries you keep that on the license plate, you'll be able to figure that. But I'm going to put registration year. Let's just keep it simple. I'm going to put registration year in there as well. What else might we have about the car? So we'd probably have some information about engine size and fuel type. Let's do that to keep it relatively short. So let's do fuel type. We'll have Oh, what did we say? Engine size, didn't we? Oh, color. Good point. Good point, Alex. Engine size. Color. I'm going all UK spelling on you all. I'm going to use my U. We've got color. And what other key thing would we want to put in here? Oh, you know what? I think previous owners. Hold that thought, because that's a really good one. So I'm just going to take that, cleanly, I'm just going to take that and put it in as a comment. And you're going to see why. You'll see what I do here, but that is super good. So let me put in a comment in here to remind myself in case I forget. That is superb. So, because that's probably going to come down to modeling. I'm going to insert another column in here, and I'm going to put in two columns. Owned from and owned until. Because we want to have that information, don't we? We want to know about, so you're an owner, you own a vehicle, but obviously at some point you acquired that vehicle, and at some point you'll dispose of that vehicle. So let's do that. Let's keep it there for now. So we could add more information in this, and maybe we will as we go through this. But for now, let's keep it there. We've got some interesting things in here. So we've got these fields. So I'm just going to take a quick copy of these, and I'm going to pop them into my notepad so I can remember what these look like. One moment. Sorry about that. Right, I'm just going to quickly transpose this so I can put a copy. And then let's do some initial modeling. So let's think about, I'm going to put in a new tab. So what type of questions would we ask? So we've got one question there which clearly suggested, which is previous owners. So previous owners is one. We would probably ask, who owns, what car does somebody own? A few of these questions. If you've got any questions that you would ask, pop them in the chat. And what we're going to do is I'm going to pop over here and let's draw out a diagram, a normalized view. So this is probably going to be a bit clunky, so bear with me. I've not used this before. Okay, so we've got person. And in person, let's make it a little bit bigger. We are going to have, does it let me, how do I, this is when I discover I can't actually put attributes in. So let's see, so person. How do I, add attribute, there we go, that's what we want. So let's put in some attributes. So they have got a name. They've got a license number. Ooh. And license number would be our primary key here. Okay, so we would then have vehicle. So let's do okay, right, we know we right click and do add attribute. So here we will have a license number. Oh, sorry, registration. We would have a make. We would have model. We would have a registration year. Now, this is where it gets interesting, because if we were splitting, so the whole idea of normalization, when you think about it from databases, so the whole point of normalization is what we're trying to do is we're trying to remove repeating data. Now, this is where it starts to get fun, because the idea is you split something out if you've got repeating data, because you don't want to keep putting it in. So, this is going to be fun. So what we'd technically have here, maybe, so bear with me as we go through this. So we'll have a registration year, and let me do this, and then we'll fix it afterwards. And I think hopefully this will make sense as to what's going on. So we've got registration year. Let's keep adding the rest of these bits, and then we can talk about what's going on. So we've got registration year. We've got a fuel type. We've got attribute fuel type. We have got an engine size, and we've got a color. And then what we would do here is, how do we connect person to vehicle? So bearing in mind that what we're trying to do is reduce duplication. So a person may own more than one vehicle. And we're talking about ownership here. So we're going to keep it nice and simple. We're not going to worry about who's driving what vehicle. And generally, only one entity can own a vehicle. So in the UK, if you've got a logbook for a car, you can't have more than one owner on that logbook. It has to be one person. So it's so person to vehicle, you've got a one-to-many relationship. So you can have, person can have, this is where we start going down the UML rabbit hole. So the relationship between person to vehicle would be one to many here. You can be a bit, what's the word? You can be a bit specific and go, well, hang on a minute, person doesn't have to have a car. But if we're assuming here this is a car ownership database, then we wouldn't add a person here if they didn't have a car. Although I'm now rapidly going to retract that, because what if you scrap the car? So, okay, it'd be a 0 to 1 to 1 to many. Sorry. 1 to 0 to many on the vehicle. Right, there we go. Got there in the end. So let's put in that relationship now. Let's put an association. Why not? Right, how does this work? Do I just, okay. Aha. Oh, no, hang on. Can I just do this? How does this work? Oh, there we go. Okay, we got there in the end. Let's not worry too much about the relationship type. We'll keep it simple for now. Let's not. Now I can't get rid of these. I've got the I've got the thing, and now it won't go away. Right. So we wouldn't have this, actually. I just realized this is wrong. Let me get rid of this. So what we'd have is, we're going to have a mapping table between these two. Because what we don't want, so the reason why we've split these out into two entities is, what we don't want, if we think about having this data here, we would, if we had a person called Jane and her license number 1345, she could easily have more than one car. So she could have a Volvo State. I don't know. I should have picked something I know names for. And she could have, let's say that's like the family car, and maybe she's got something a bit sportier to use when the weather's nice. So let's say there is a Mazda MX-5, I think is like their fancy one, isn't it? So if we were looking at this as a flat file, we'd have this sort of denormalized data. So we'd have this Jane and license number repeating continuously for each new vehicle that's in there. So we have this duplication. And what we're trying to do when we're normalizing data, so this is why we go to this effort when we're working with databases, we're trying to remove the repetition. Because what happens if Jane changes her name to something else? Then we have to go off and make sure we update every single record in there to make sure we've not missed something. So this is why normalization is so important. So we'd have a mapping table here. So let's call this person vehicle. And we would have something like this. And let's not worry too much about direction for now. And we would have, let's just make this a bit bigger. We would have something like license now, because that's our primary key from the person table. And we would have something like registration no. I'm just going to make these short because I don't want to keep typing these out all the time. I'm lazy. Okay, so this is our mapping. Oh no, don't do that. Okay. So this is our mapping table, and this stops us from having duplicate persons. So if we've got a person that owns more than one car, that's not a problem. We just repeat in the person vehicle mapping table and all is good. Now, this is where it gets fun because, and I'm going for this exercise because you're going to see this happens when we're doing graph modeling as well. So what you would see, actually, let's do the same thing now. Let's do exactly the same thing in our graph data model. So this is our normalized, but we can do some more to it. And I can't remember the various names of this. You're going to have to forgive me, but I'll be back on this in a second. So this would be roughly what our normalized data model would look like. So what would this look like in the graph? Well, it's simple. We'd have a label called person. And we've got some properties on here. So we have got name and we have got license number. And we would then have another node. This is going to be vehicle. And we've got some properties on vehicle as well. We have got, and I'll come back to the owned date thing as well. So we will, I'll come back to it in a second. I've realized I've missed this out. So let's put in the reg number. We're going to have a make. We have a model. We have a reg year. We have fuel type. We have an engine size. And we have color. So good so far. Right, let me just move these so that you can see all these wonderful properties I've put on there. And again, as you will recall, the big difference between a graph modeling, so graph database and a relational database is, in a relational database, we do our joins at the time of read. So what we will do, there is no join that joins together person and vehicle. We have our mapping table here. And what we're going to do with our mapping table, we call this in at the time of read. So if we have a query that says, give me all the vehicles that Jane owns, what we would do is we'd look up Jane in this table. We'd get Jane's license number. We'd then go over to the mapping table and we'd look up the license number we found for Jane in this table and then find all of the vehicle reg numbers that matched against that license number. And then we take all of those registration numbers and then go over into the vehicle table. We'd map against the registration number we found in this table, but map to the license number that we found for Jane in this table. And we then list out all the vehicles. So that's what we're doing there. So we're doing a join on read. So we are reading the data and then that's how we're joining the data together. Now let's come back over to here for our graph data model. So we are pretty much in the same structure. So it all looks very, very similar. And the difference here is we do a join on write. So in Neo4j and graph databases, typically we do a join on write. So as soon as we know there is a connection between a person and a vehicle, we put a relationship between the two. So if we wanted to find out here how many cars or what cars does Jane own, we'd go to this node, we'd go and find Jane. And then we don't worry about the license number. What we're going to do here is going to say, right, now find all of the outbound, let's give this relationship type. Find all of the outbound relationships from this person over that owns relationship. And these are all of the vehicles. So that's a great example. So we've got one question that's come up. Is it used for anti-money laundering? Yes. So anti-money laundering is a very popular use case for Neo4j. Very, very popular. And just literally Google Neo4j, AML, you'll find a bunch of stuff. Okay, so that's that so far. Now, let's come back because I realised the one thing we've missed out is a bit of data, which is our owned from and owned until. So let's just correct our data models. So this is where it starts to get interesting, because remember what we're trying to do is we're trying to reduce the repetition of data. So the interesting point here is, where do we put this owned from and owned until data? Now, for the sake of keeping it relatively straightforward, I'm going to pop it into the mapping table, although I need to have a little think about this. I'm not crazy about putting it in here, so we'll probably have to have a think about where is a more appropriate place to put it. But for now, we are where we are. So let's put that in. Oh dear me, I'm very sneezy. I think it's gone from cold to hot, and when I have these massive temperature changes, it sends me off in sneezing. Okay, so I'm not crazy about this. So I'm probably going to find a better place for this, but for now, let's do it here. Owned from, and then owned until. Oh, don't want to do that. Oh no, right, I need to make some more space, don't I? I need to make my mapping table a bit bigger. No, I don't want to do that. Aha, there we go. That's what I wanted. So let's add an attribute, owned until. So I'm not too crazy about this. And the reason why I'll tell you why I'm not too crazy about this is we wanted the mapping table where we found the person from the license number, then pull out the reg numbers that compete. So now what we're saying here is, because we're capturing that car could have been owned by more than one person, as was raised by Clooney, what we can do, so here we're going to end up with multiple license numbers. So this may be the right place to put it, because it's still distinct data, so we're not duplicating anything in here yet. I mean, we could probably pull this out, but we're going to leave it for now. And what we'd do is, if we were querying this, we would put in sort of our ranges for owned from and owned until. But for now, let's go back and do the equivalent here. So what we would do is here, the most obvious place to put this state data. Oh, we're going to have to do a modeling series on tracking change in your data, but not today. But this almost is like the state thing. But anyway, let's put some properties on here. So owned from and owned until. And that's how we're keeping the equivalent data here in our graph. So as you can see, we've got all of the same data that we have in here. We have in here. So good so far. Now let's go back to this sticky subject. So this is all about, so your data model, and this to some extent, not quite the same in relational, but you'll start to see some points. So here, we're always thinking about what question we're looking to answer. And this is true too of any data source. The question that you're looking to answer will inherently at some point change what your data model looks like. But let's come back here and let's talk about, why was I feeling a little bit about the vehicle? So remember, what we were talking about is, how do we minimize the amount of repetition that we have in our data? And what we can do here, if we look here and have a little think about what's going on in vehicle, we've got registration number, that's unique, great, that gives us a unique value for our vehicle, fantastic. Then we start to come a little bit unstuck. So we've got make and model. Okay. Reg year, well, okay. So now it starts to get a bit interesting, because the registration year is registration year to vehicle. So we'll probably go, we'll keep that with the registration number. So that kind of makes sense. So let's, I think I can make this, can I make this go up? Can I drag it up? Oh, I'm stuck. Oh no. Tool limitation. Will it, order. Oh no, I can. No, I think that's for the shape. Never mind. Okay. If I could bump this up, I would bump reg year up to, no dear. We'll go reg, relation crazy. So I bumped this up. So okay, registration number and registration year. Fair enough. We'll keep that up. We're not worrying about duplicate there because that's just it's an integer. Yeah, so what? The interesting thing here is we've got make, model, fuel type, engine size. So these are things that I could argue we can pull this data out because maybe we could say, well, actually, this is duplicate. So if you think about color, again, I'll probably keep with the reg year and reg number. But make, model, fuel type, engine size. These are things that duplicate potentially over and over again. And it depends. You could have it here, but you could say, well, actually, I could extract this out. So let's do that. So let's bring up yet another class. And let's call this. I'm not going to go too crazy with this. So let's call this vehicle info. And generally with vehicles, you will have, as with most things, you will have some kind of a stock keeping unit or whatever the vehicle equivalent is. So let's call it I don't want to call it a serial number because that's wrong. That'd be a unique thing. But let's call it a stock keeping unit. I'm sorry, I can't think of anything better here. So that's going to be its primary key here. So that's our unique identifier in here. So let's do a stock keeping unit. And then within there, we're going to say, well, actually, a stock keeping unit will have a combination of a make, model, a fuel type, and an engine size. If you go onto a Ford website or a Honda website or what have you, and you pick a car, it forces you down certain steps to pick. So if you pick a certain model number, that's the one I was looking for. If you pick a certain model number, it kind of forces you as to what choices you can have. So let's do that. And you can only have a certain number of engine sizes and that kind of thing. So let's do that. I'm going to change this to model number. Okay, right, I'm happy with this. So that's probably what it looks like. So now that we've got this vehicle information, we've removed the duplication going on in this table. Because again, if we pick an example, the number of people who have got a Honda Jazz SR semi-automatic, loads, thousands, hundreds of thousands. So you've got that piece of data repeating over and over again. Whereas by pulling that out, this table becomes smaller. It doesn't become smaller, but the amount of data we're replicating becomes less. So let's pull out all of that information. So remove make, let's remove model, let's remove fuel and engine. Oh no, do not remove that. That's fine. So now we're left with the things that are sort of unique-ish to the owner. We've got the vehicle information, and we just need to put in a mapping table now to join these together. And you can see we have reduced some duplicate data. So that's our mapping table, and let's just make this a bit bigger. Again, shout if this doesn't make sense. Do give me a shout. And here we do a relationship to here. And I'm going to do a relationship to here, and let's just put in our primary foreign keys even here. So let's put in our uniquely identifying keys. So here it's going to be reg no, and then we're going to have model no. And there we go. We have pretty much normalized our data more or less. I mean, like, you can keep going, but we've reasonably removed a lot of duplicate data that would have been appearing. And that's kind of the goal here. Now, the fun bit here starts. I don't know what's going on with the relationship there, but it does not matter. Anyway, doesn't matter. Cool. So this is us normalizing for reducing the amount of duplicates in our data. And that's typically what we'll do in a relational database. But this will change according to what we're trying to do. So if we were asking loads of questions over and over and over again about the make and model of a vehicle, you can see here the problem that we have is if we wanted to ask the question, what vehicle model does Jane drive? We have to do a lookup. So find Jane, find license number, look up license number in our person vehicle mapping table. We then go to vehicle. We then find we're going to pull the, I forgot to add. Oh, no, it's right here. So find the reg number, and then we're going to cross over to here. And then maybe we might optimize and go from person vehicle straight into vehicle info. That is your decision. You've just got to bear in mind about where you keep those relationships. But anyway, jump into vehicle info. We then find the model number. We then go to vehicle info and then pull out the model. That's a lot of joins. That, depending on how you set up your indexes and such, is quite slow or can be very slow if you're not careful and you've got a huge amount of data. Okay, but you can see what we've done here. We're trying to reduce the amount of duplicated data. Great. Let's move over to the model side. So the graph model side here. So if we came to the same situation here and we said we wanted to ask the question, what model does Jane drive? That's fine. But what you'll notice here is, again, we are potentially subject to a bit of duplicate data. Now, up to you what you want to do, but we can also do the situation where we can say, well, actually, we're a bit concerned that if I can't think of an example offhand, but let's say the name of the company changed and we wanted to update all the things. Yeah, we've got the same issues as well. Now, the reason why we'd be thinking about refactoring this data is what kind of questions do we want to ask? So the driver behind this will be, well, what if I want to ask questions about what's the most popular vehicle model? So at the moment, if I wanted to find out what the most popular vehicle model is, I would go to the vehicle node and I'd do a count on model. But what we can do as well is, if we wanted to explore more about make a model, we can do a similar thing that we did over here, and that is, let's pop out the vehicle info. So let's do that. Oh. And let's put in some properties of vehicle info. So we are going to have the make, actually, this is a good point. So actually, before I go off on this, let's talk a little bit about why do we do things. So this is driven by what question we're looking to answer. So if we go back here, let's think about what questions we want to ask before I attack that data model. So we still have the same thing here, that if something changes, so if the make of the car, so let's say the name changes, and I'm just trying to think of an example where a car has changed. I can't think offhand of one, but if the name changes, then we can reduce the number of places we make updates by popping this out. So you have that option too. But the thing around this would be, what questions are you looking to answer? So we've got previous owners. Let's have a look at previous owners quickly. So do we need to update our data model to look at previous owners? So how we'd answer that is, we would go from here, from the vehicle side, and then from the vehicle side, we'd look for all of the relationships where there's an inbound owns relationship coming off of vehicle. And that would give us a list of person nodes. And that would give us the answer. So that would be the answer of all of the previous owners. So we don't need to update this data model. This data model expertly fits our use case. So we don't need to make any changes there. So that's good. Let's look at the next question we had in here. What car does a person own? Okay, let's go back to our data model. We look up our person in the person node. We traverse the owns relationship, so all of the owns relationships that are outbound from the person node. And we get some vehicles. Great, we can answer that question. So don't need to update the data model. It's spot on. What other questions might we ask? So let's think about the more connected questions around this. So maybe something we might ask, what's the most popular make and model? Maybe we'd ask, I'm just trying to think, sort of incremental steps. Maybe another one we'd ask is, what's a person's car journey? So they start off with, I'll start with me. I've got a very boring car journey, which is I owned the Peugeot 205 and now I own a Honda Jazz. But maybe we could look at the different cars that people own over time, just to have a little bit of fun with looking at the pattern. So what is a car ownership journey look like? What does a car ownership journey look like? What other sort of graphically connected questions would we want to ask and find out based on cars and owners? We'll have to think of a more fun data set for the future. How about, let's have a look here at our data model. What about engine size? I think that'd be an interesting one. So let's think about the box, and I'll talk about why I'm suggesting these in a bit. So let's look at engine size. What specifically about engine size? Let's do. Oh my goodness. Again, any ideas? Check them out. Oh, we can do a bit of fun where we do bucketing of engine size to number of owners. So let's do. Let's stick with that for now. So let's have a look at, so this one we've said, first iteration, most popular make and model. Let's have a look at what's going over here. So if we wanted to answer the question, what's the most popular make and model? The problem that we have, I need a title on here. This would make it more sense. But anyway, so if the question we want to answer now is most popular make and model, can we answer that question now? So we can. That's not a problem. So what we'd do is we'd get all the vehicles, we'd then go into the properties, find the make and models in the properties, and then what we would do is we'd then sort of summon these. But the problem with this approach is, let's say we've got, I think there's something like, I'm guessing now. So let's say there's 30 million cars in the UK. So effectively what's happening here is if we wanted to do a query on the property here, we'd have to go off and look up 30 million vehicle records and pull up their properties. And we know there's going to be a lot of repetition in here, because bearing in mind, let's pick Honda Jazz, there's going to be hundreds of thousands of Honda Jazzes on the roads of the UK. And we're going to do some aggregation there. So we've got a lot of duplicate data. So if we want to answer this question, it makes sense now to refactor our data model. So let's do that. And it's, pretty straightforward. So let's do this. And there's a couple of ways we can do this. So we can do this like a tree, or we can do this like a how we grouped it. So let's look at it as a tree to begin with. So let's do a make. And let's just, I'm wondering how I make this a bit smaller. I will find out soon enough. Got make, and we're going to have a model. There we go. Right. Model, and I'll talk through what's going on here. So we could say, well, we're going to refactor these. So let's add in some properties. So make, let's do name, and the model is, I'll just give it a name as well. Can't think of anything particularly exciting for that. So let's do name. Okay, so we can now get rid of make a model here. So what we've done now is we've reified our data model a bit, and we had a couple of options of how we could do this. So we can either do it like this, because we know that model is going to be of a make into vehicle, or another option you could have done is you could have had model come off of vehicle. Let's talk about the pros and cons of each one. So let's quickly look through what happens now. So if I want to do a query on what's the most popular make now, so whereas before I had to go into vehicle and I had to do a bunch of querying on here and pull the properties, now I'm going to have a unique node for each make. So immediately I've gone from 30 million lookups, if we're looking at the UK, for example, to look at all of the properties here 30 million times. Now I'm only going to do it, I'm going to be generous here. Let's say there's 100 different makes of car. So now I've just got 100 nodes. So immediately I've got something that's a lot quicker and to the point. I can go from make to vehicle now and find out the counts. And we can now do groupings by what are the most popular makes. Same idea with models. So in this situation here, we can go from make to model. So this is going to give us a distribution of model to make to vehicle. Or what I could have done here is I could have done vehicle to model and got rid of this. And then I go straight from vehicle to model. So this will be faster. So if we're in a situation where we're going to be asking just as often how popular a make is and how popular a model is, then this is a little bit faster. Now, you may decide, well, actually, it doesn't need to be that fast. And for me, it's more important to have this sort of hierarchical view. You may go down this route. So there we go. We have refactored our data model. And if we come back to our questions, most popular make model. Now, with our second iteration, we can now answer that question. What does a car ownership journey look like? So this is where we want to know what different cars someone has owned. So does our data model allow us to answer that question? So let's check. So what we're going to do is we're going to be having a look at all the different cars someone has owned. So if we go here, person to vehicle, we can already answer that. So we don't need to do anything. So we would find all of the outbound relationships coming from vehicle. If we need to get the make and model, we can just go down. And the previous data model also answered that. And then we just go back and forth. So that's fine. So data model iteration 1 would have happily answered that. So let's do the last one. I think we got through it a lot quicker than I thought we were going to. So let's wrap up with the last one for the iteration of the data model. And again, if you want me to add any other questions, and I saw Alex has mentioned age of person, birthday could also be interesting. Yes, so let's add in date of birth in here before we forget, and we'll look at that next time. date of birth. So we'll look at that one next time, but let's go back here. So if we want to answer this question here, which is number of owners related to engine size. So this is a bit of a two-stop one. So what we'd do, can we answer the question, the relationship between owner to vehicle engine size? This is again similar to our make and model one. So we can, but we've got a lot of replication going on here. So you're going to have a lot of engine sizes that are quite similar. So like 0.9 litres for those really tiny engines to maybe 5 litres for your muscle cars. So you've got range, but the point being you've got a lot of discrete values. So it makes sense to pull out potentially engine size as a separate node to investigate. So what we can do is we can pull this out and we can put in the engine size. Remove it from here. And now we can ask that question. So you can see what's going on here. So this is iteration number 3. So let's quickly talk about this before we call it a day. And what we've got here is, what you've noticed is we've been pulling out values as and when we've been further and further iterating our question. So if we never asked a question about engine size, then we probably wouldn't need to pull this out. We could have just left it where it is. But because we're asking those questions about engine size, we I've pulled it out now. So that's kind of our rule for when does something become when is something a node, or when is something a property. A lot of it's going to be driven by how often are you asking a question. And if you're asking lots of questions about engine size, then it makes sense to pull it out. So value. There we go. So that's pretty much it. So let's leave it there for now. So we rattled through a lot of stuff. Have a little think about if there's any data sets you'd like to look at. And I will leave it there. So I hope you all have a wonderful day. And with that, I will leave it there, and I will see you next week at our normal time of 4 p.m. UTC. See you later. Bye.